Hey guys, welcome to the introduction on micro-partitions and clustering. Let's start with the basic definition of partitioning. Partitioning in any data warehouse or database is a process of dividing a huge dataset or table into smaller chunks so that each of those partitions or chunks can be manipulated independently. Now, when I say manipulated, I'm essentially talking about fetching the data, your read queries, update queries, or even delete queries. When it comes to Snowflake, the same partitions are referred to as micro-partitions. Why micro? Because each of these partitions can only hold data in the range of 50 to 500 MB, and hence the term micro-partitions. And the best part about Snowflake is that it handles the micro-partitioning process automatically. You do not need to explicitly define or tell Snowflake to do this for you. And also keep in mind, these micro-partitions can overlap in the data that they hold, which we'll be looking at in detail at a later stage. Each of these micro-partitions have metadata, and these metadata can contain the range of values for each of these columns inside of the micro-partitions, let's say the min and max values. It can also have a number of distinct values inside of those micro-partitions. And there are certain additional properties which is required for efficient query processing. Now, all of this metadata is contained or stored in the cloud services layer, which is the brain of Snowflake. If you remember in one of the previous slides, I talked about the different layers Snowflake has. So this is where cloud services layer comes into picture. It plays a pretty key role when it comes to partitions, micro-partitions, and clustering. Now, what is clustering? Clustering is a process to optimize your data retrieval process. All right. Clustering is performed inside of micro-partitions to ensure similar data reside in the same micro-partitions, which can be then fetched in a single query. Clustering keys is a column or a group of columns that are designated to locate the data inside the same micro-partition. Now, these clustering keys play a key role to ensure the data is sorted or ordered inside of those micro-partitions, which especially helps when you query huge or amounts of data or large tables. Now, you would also hear the term pruning quite often in any of the videos that you watched or even down this course. So pruning is a process where Snowflake avoids unnecessary scanning of micropartitions. That's the definition of the word pruning. As long as you use your where conditions in your SQL statement properly, it'll help Snowflake to ensure you do not scan unnecessary data. So pruning is a process where Snowflake knows what to avoid, basically. On a side note, Snowflake automatically splits the table into clustered micropartitions using the natural dimensions or natural obvious columns like your date columns. So Snowflake, when the data is ingested into a table or when you're creating table in Snowflake, which has huge volumes of data, Snowflake applies some common sense. It says, hey, this table has a date column. So it'll probably automatically split the table basis the date column that you have. However, these clustered micropartitions might not be necessarily ideal in a long run, meaning later down the line, as in when you understand the workload of your Snowflake or your pipelines better, you might realize that there is a need to explicitly define the clustering keys so that the micropartitions work better, which in turn will have a direct impact in your performance. So I hope theoretically speaking, the concept of micropartitions and clustering was pretty straightforward. Now, let's go back to our Snowflake UI. I'm going to click on the Snowflake sample data database. And we've already seen the schema. This is the schema that we'll be working with throughout this course. Let's hover on one of these tables. Let's say customer. Now, if you hover, it'll give you some information about each table. The table name, when was it created, how many rows exist, and what's the size of the table. Looks like the customer table is not clustered. But if you hover the next one, which is line item, you see the last value, which is clustered by. It tells you this table has been clustered by the column L underscore ship date. Now, for the sake of simplicity, let's look at part sub table. Just preview the data once. Let's bring up the results. Now, if you hover on this table, Snowflake tells you that this table has been clustered using the PS underscore sub key. Now, this table basically has information about your part. It has the part key, it has a supplier key or sub key, It has the available quantity, it has the supply cost and some comments. This table is clustered using this column, PS underscore supply key. Now let's go back to our slide. On the left hand side, you see the logical structure. And on the right hand side, this is the actual physical structure with micro-partitions. I've taken the sample data out of this table, and this table has been clustered using the PS underscore subkey column, right? In this sample, this column has three distinct values, 4078327, and the second one is 220164, and the third is 4078327. Since this sample has three distinct values, Snowflake is going to create three micro-partitions, and each micro-partition holds one supplier key. Okay, so the first micro-partition has the one that starts with 407, the second one, the one that starts with 220, and the third one is the 7991. Okay, so you have three micro-partitions. Since we all know Snowflake is a columnar storage data warehouse, this is how it will actually store the data. So you have your first micro-partition, you have your columns here, since Snowflake is columnar, and you can see the supply key or the sub key for 4078327 is stored in this micro-partition, so on and so forth. Now, if you fire an SQL query, let's say on this table, select part key, PS underscore part key, and PS underscore supply cost from the table where, and keep in mind, the where clause or the where condition is extremely important when it comes to pruning, especially if you are querying huge tables and you want to ensure Snowflake does not scan unnecessary micro-partitions. You have to ensure you use the clustering key in your where predicate or your where clause. So if I say where PS underscore subkey is equal to this, it's quite obvious that Snowflake knows this is the micro-partition where this value resides. So it's only going to scan micro-partition 1. In other words, it also means it's going to prune micro-partition 2 and 3. So that's how, on a high level, you optimize the way your data is distributed in tables and how you actually scan the data inside of your tables. So I hope the theory was clear enough. Next up, we'll be having some practical sessions and lab sessions where we'll be writing some SQL queries to better understand the concept of micro-partitions and clustering keys. So I'll see you guys there. Thanks for watching.